Alright guys, final review, part 1, the second half, so I'm going to call it part 1B. So we left off on number 7. It says a side of a square is 1/4 of the size of the side of another square. What is the relationship of the area of the smaller square to the area, and then of the larger? Got to move down here, of the larger. So we have a ratio between side lengths, right, of 1 to 4 between those two squares. Well, we know we can represent that ratio in the form of a fraction, right? 1/4, and we learned that if we have the ratio of side lengths, we put it a over b. Well, the ratio of the areas is just a over b squared. So if we wanted to find out the ratio between the areas, well, we would just square this guy. And we find that the ratio between areas is 1/16, or 1 to 16. So you just look at your answer choices, and it's actually going to be answer choice, I think, D. The area of the smaller square is 1/16 the size of the area of the larger square. Okay, so I'm not going to read all the answer choices just to save time on the video. You can go back and read the other ones and see why those were not correct. But D would be our answer. Okay. So moving on, question 8, got a little trig, our favorites, right? So we got to find side x. We got to find x and round to the nearest hundredth. So first of all, let's just label our triangle. Excuse me. Let me get a drink of water real quick. All right, so let's label our triangle first. So we got our angle here that we're looking at. So this guy right here, well, he's going to be opposite, right? He's opposite of that angle. Opposite of the right angle is always that hypotenuse. That leaves this guy to be good old adjacent. So notice we have adjacent, and we need opposite. So we're going to use the trig function that uses those two things, and that's TOA, right? TOA. So out of SOHCAHTOA, or right, it's just so you know where that comes from. SOHCAHTOA, right? So we know we're going to use TOA or tangent. So the formula for tangent is tangent theta equals opposite over adjacent, right? So then we just plug in the stuff we got, right? So then it's tan, and theta is the angle, right? The angle measure. So tan of 64 equals opposite. That's what we were looking for. So I'm gonna put an x there, and adjacent was 11. Okay. So then we just solve for x, right? So we can put this guy right here over 1, change colors, and we can cross multiply or butterfly, right? And so then we'll have tangent of 64 times 11 equals x, and then that we just got to put in our calculator, right? So let's do that. Go turn it on. And always go to look at the mode. Make sure we're in degree mode. If we weren't, you'd come down, boom, boom, go down, go over, and click on degree. Make sure you get in degree mode. And then it's just tan of 64. Close those parentheses, right? Because that makes it where it only takes it up to 64. Because then you got to put in times 11 after that. And we'll find the answer is 22.55, which was answer choice C. Answer choice C. Okay. So not too bad. Let's keep moseying. So question 9 says 2 cubes have surface area of 72 square feet and 98 square feet. What is the ratio of the volume of the small cube to the larger cube? Okay. So again, just like, what was that number? We're just there. Number 7. So number 7, it goes back to those ratios, right? So we learned if we had the ratios of side lengths, well, if we needed the ratio for the areas, you just square it, right? So it's just that squared. Well, then if you needed the so this is let me call this dimensions. This was the areas, and then if we needed the ratio for the volumes, well, that's just a over b cubed. So this would be for the volumes. Okay. So now they want to know the ratio between the volumes. Well, we have 2 areas here, so we can set up set up a ratio between those guys, right, of 72 to 98, right? But we're always going to put in a fraction because that we can work with. So 72 over 98 would be our ratio of areas, right? But we can simplify that, right? We can divide each of these guys by 2 and make that guy 36 over 49. That's the ratio between our areas. Well, we need to go back to the dimensions, right? We need to go back to the side lengths, the ratio between side lengths, or in this case, edges, right? So then we can cube it and have the ratio between volumes. Well, if we're here at the square point, to get back to here, we need to, right, take the square root of that guy, right? So we'll take the square root of this one here, and so then the ratio between our dimensions will be 6 over 7. Okay, and then but we need the ratio of the volumes. So to get there, we just cube it. To get our final answer, we cube this guy. So then our final answer will be 216 over 343. Okay, which is answer choice D. Okay, not too bad, not too bad at all. Again, let's just reiterate. I mean, the big thing to know here is that if you have the ratio between dimensions or side lengths, you square it to get the ratio between areas, and you cube it to get the ratio between volumes. Okay, but we were given the areas, so we had to take the square root to get back to dimensions, and then cube it to get to the ratio of the volumes. Okay, I hope that makes sense to you guys. So question 10, these are straightforward. It says which of the following is equivalent to the degree measure for 4 pi over 3 radians. So going from radians back to degrees, we see our answer choices are in degrees. So remember, to do that, all you do is that 4 pi over 3 times 180 over pi, right? I told my class, you always know you're doing good going from radians to degrees if the pi's cancel, right? And the pi's cancel here. So then we got 4 times 180, that's 720 over 3, which is 240, right? 240. So answer choice B. Not a problem. If you're going the other way, remember, if you're going from degrees back to radians, you multiply by pi over 180. Opposite of that guy. Okay. So then number 11 says find the area of each shaded sector. We'll find the area of this sector. It says round to the nearest tenth. So we're going to find the area of that sector. So then you got it on your formula sheet. You look back and remember that area of a sector is just area equals, it's always the measure of that angle, the measure of your angle over 360 times area of a circle times pi. Whoa. What happened there? So times just all over the place. Alright, times pi r squared, right? Because it's the area of a circle, right? This would give us the area of this whole circle. And then this fraction right here, it tells us what part of the circle we want, right? It tells us, well, we just want 37 degrees out of the full 360 or whatever your measure of your angle is. Okay, and that's how that formula works. So then for that, it's just area equals, again, measure of the angle is just this central angle. It's 37 over 360 times the area is the whole circle, right? Pi, our radius is right here. It's 19. It's all over the place. Times 19 squared. Okay, so that we just put it in our calculator. I'm gonna show you. I'll put it all in there one line. Make sure you don't make any mistakes. So 37 over 360 times pi times 19 squared. Okay, and we'll see we got 116.6 rounded to the nearest tenth, and that's answer choice Answer choice B. Answer choice B. Okay. Not too bad, not too bad. Alright, so number 12, we got some probability. It says, in a game, a spinner with 8 equally sized sections, numbered 1 to 8, is spun and a die is tossed. What was the probability of landing on an odd number and then spit on the spinner and then rolling an even number on the die, right? So we learned that, well, these two things are independent, right? Because no matter what we do on that spinner, it's not going to affect what we roll on that die. So what we can do is just find the probability of each event and then multiply them, right? Well, the probability of that first event of spinning that spinner and landing on an odd number, well, the odd numbers, right, we got 1 through 8 are going to be 1, 3, 5, and 7, right? So it's 4 of the numbers, 4 out of 8, right? So it's going to be, you can say 4 out of 8, or 1/2, right? So 1/2. Well, then the probability of rolling a die and getting an even number, well, you got 1 through 6, right, on a die. Well, the even numbers are 2, 4, and 6, right? So 3 out of the 6 numbers, or again a 1/2 probability. So then we got times 1/2. You can just multiply the probabilities of each event, and now we have a total probability here of 1/4. Or answer choice D. Okay. So moving on, question 13, last one for part 1. So it says, given the following coordinates of triangle ABC, what would be the new coordinates for A prime under the given translation? And then we're given our 3 points here. Here's our A, really, because all they want to know is A prime, right? So A is the only thing that really matters. And then they have that, what we call the translation vector, right? And that told us, when we read this translation vector, that told us we're going to go, we're going to move down 3 spots on the X. Or actually, it's going to be to the left, right? We're going to move to the left 3 spots on the X, right? -3. And we're going to move up 5 spots on the Y-axis, right? And all we did with this is, well, we just took it. What that told us was to take whatever our point was and to do X minus 3 and to do Y plus 5. That's what this translation vector told us. So then if we just want A prime, our new A, well, we'll take point A, which was 2, -5, and we'll get to A prime by subtracting 3 from 2. So that would be -1, and subtracting or adding 5 to -5. That'll give you 0. So we'll find our new A prime is at -1, 0, which is answer choice A. So A prime is A. Alright, so that's it for part 1. So we'll pick up again on part 2 of your final review.